All right, hey guys, welcome. We are looking at Algebra 2's 2.4 today. I mean, today for you. This is right after 2.3, so let's have at it. 2.4 is about relations and functions, and good news for a lot of you guys, I'm sure. Um, Most of this can be done just by looking with your eyes. You don't have to do much actual work in this lesson. So, 2.4, you guys know the drill. You don't have to write, this stuff. This is just, headlines, and then you should write down 2.4 relations and functions. All right, go ahead and pause the video. I'm going to move on. If I can find my transition here. All right, so definitions. Everybody's actually. I told you guys not gonna have to write stuff, and then immediately you're writing definitions. I mean, you don't have to do much in the way of working out stuff in math. All right, there's still definitions you should know. All right, so a relation is just a set of ordered pairs. Okay, just a set of ordered pairs. And you guys may be like, what's the point? Well, we'll get to that later on. All right, so the domain and range, two of the most difficult definitions for students to grasp in my experience. So domain and range. Domain is the set of all x values of a relation. Right? That's a simple way to think about it. On a graph, it's harder to understand than this definition provides. The range is the set of all y values. So the set of all x values for the domain, the set of all y values for the range. All right, and then a function. A function is a relation or a set of ordered pairs in which every x value only has one y value. That means that if this was your relation and you wanted a second ordered pair like this would not be a function, because a function has to be a relation where every x value only has one y value. So here, if you look, your x value of 4 maps to 2. So for 4, it went to 2. Right? That's the one y value for this x value. But right here, it's saying that 4 went to 0. That's saying that the same x value has two different y values. That means this is not a function, okay? Does that make sense? So this is an example of a relation that would not be a function, okay? So not a function. All right, so moving on. Given this relation, what is the domain and range? Is the relation a function? Okay, so domain is just the set of all x values. So that is 1, 2, 3, and 4, all the x values. That's it. So your domain would be 1, 2, 3, and 4. These things here are called braces, just as like an FYI. These things are called braces, and they denote sets. And sets are a complicated, well, I don't know. They are fairly complicated, and to understand them fully, like that's like college level stuff to understand sets. This was like abstract algebra was like mostly about sets, but a set is just for you guys just like a grouping of numbers basically, or a grouping of anything, a grouping of ordered pairs, a grouping of numbers, a grouping of I don't know whatever else you want to group. All right, so then range is the set of all y values. So here are your y values. And you don't want any repeats. So you have 6 twice and then 8 and 9. So you've got the set 6, 8, and 9. And there you have it. There's your domain, there's your range. Now, is this relation a function? So to be a function, a single x value can only go to one y value. So here, is 1 used again, no. The x value 1 is not used more than once, so that's okay. And if you look here, none of these x values are used more than once. So there's no way that they can have one x value mapped to multiple y values if it's not even used more than once. So 1 went to 6, 2 went to 6, 3 went to 8, and 4 went to 9. Now you might be thinking, well, Mr. Dybel, how is this a function? 6 is used twice. And yes, that's true. But the y values can be repeated by the definition of functions, okay? Like don't complain to me that it doesn't make sense. It's just by the definition, right? So y values can be used more than once, but the same x value cannot use multiple y values. So if this was also, actually no, if this was a 1 and it mapped to 8, then it would not be a function because 1 mapped to 6 and then 1 mapped to 8, okay? But here, this is absolutely a function. Yes, it is a function. All right. Moving on. State the domain and range of the relation, then state whether it's function or not. Exactly the same thing. So why don't you guys try to tackle this one? Find the domain, find the range, write them out as sets, and then state whether it's a function or not. All right, pause the video and go. Now, hopefully, we'll see if you got it right. I'll try to move this through this quickly. I'm assuming that you did pause the video and try. So the domain is just all the x values. So that's 6, 8, and 9. And notice how 6 got repeated. 6, 8, and 9. And then your range is your y values. So that'd be 1, 2, 3, and 4. All right, so there's your domain and range. Is this a function? Answer is no. No, it is not a function. Why is it not a function? Well, it's not a function because if you notice, 6, the x value is 6. In this ordered pair, it mapped to 1, but in this ordered pair, it mapped to 2. So since 6 mapped to 1 and 2, it is not a function. All right, that's the idea here. Now, this is another way to show relations. These are like your x's and these are like your y's. Right? I didn't specifically write that, but it would be written that way on a test or something if I gave you bubbles like this. So is the following relation a function? And the idea here is this is a graphic way to like a graphical way to show you the relation that -2 mapped to 5. So that would be -2, 5. Right? That would be one of the points among the many points here. This would be one of them, and you could make a list of points. Then 3 maps into -1, so 3 to -1, and you could write all these out if you really wanted to. 5 mapped to 3, and so on, right? So the idea here is to figure out if this relation is a function, you have to look. If these are x values, is there a single x value that maps to multiple y values? So these are the x values. So to look for that, you see, is there any x values that has not just one arrow going to a y value, but a second arrow going to a y value? That is one x mapping to 2 separate y's. And the answer is no. This just maps to 1, this just maps to 1, this just maps to 1, and this just maps to 1. So we are good. All right, so is the relation a function? Yes. All right. Vertical line test. This is pretty, this is a really simple thing to do if you know how to do it, right, basically. If a vertical line drawn through a graph touches the graph at more than one point, it is not a function. So you can draw your vertical line anywhere. So right here, well, that's not vertical, right here. Did I touch the graph at more than one point? No, I touched it just right there. Any of these lines here only touch the graph at one point. So this left example is a function because the idea here is if the line touches more than one point, then it is not a function. So if it only touches one point, then it is a function. Or if it, doesn't touch a point, that doesn't necessarily mean anything. So you can't draw a line. If you can draw a vertical line through your function or your graph and it touch more than one point, it's not a function. So there aren't any here. These all just touch the 1 point, 1 point, 1 point, 1 point, 1 point. So it is a function. Okay? So this would be a function. What about this one? Vertical line, vertical line, vertical line, vertical line, vertical lines. Am I touching the graph at more than 1 point on any of these? Touched here, 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 here. No other places. So this is also a function. And you might be thinking, well, I don't understand this yet. Well, look at this next one. Vertical line here only touches at 1 point, right? But if it is possible at all to draw a vertical line somewhere where it touches at more than 1 point, it's not going to be a function. So if you notice, if I drew a vertical line here, now we're in trouble because we've touched at 1 point, 2 point, 3 points. We've crossed at 3 points. That's a big problem. Right, so this is not a function. Okay, because you touched here, here, and here with the same vertical line. Does that make sense? All right, is the following graph a function? What is the domain and the range? Now this is where, this is where it starts getting more complicated for domain and range, trying to understand it from a graphical point of view. All right, so is the graph a function? That's easy enough. Does it pass the vertical line test? And the answer is yes. You can try to draw a vertical line and it touch more than 1 point, but you'll never do it because it never overlaps itself, right? So this is definitely a function, so you'd write yes here. What is the domain and range? Now, this is the tricky part that's hard for students to understand. I'll try to go through this really clearly. Domain is supposed to be the set of all x values of your function. So how that translates on a graph is, let me try to think about how I want to say this in a way that won't confuse you. So let's think of an x value, like the x value at 2, right? If I drew a line through this x value of 2, does my graph cross this x value of 2 somewhere along this line, this x equals 2? Does my graph intersect with this line? Yes, it does, right there. So that means that the value of 2 is in my domain. Remember, domain is x values. So think of another x value. Let's do 5. So that's 3, 4, 5. So here's the x value, like x equals 5. So that's 5. Does my graph intersect with this line? And the answer is yes. So that means 5 is part of my domain. How about negative 5? Negative 1, negative 2, negative 3, negative 4, negative 5. Draw a line here. Does my graph intersect with this line? Yes, it does. It intersects right there. So that would mean that negative 5 is part of my domain. So try to think if this graph, because of these arrows, was expanded infinitely this way and infinitely this way. Can you think of some vertical line, some value of x that my graph would not intersect? Right? All the values that it does intersect are part of your domain. Typically, it's easier to think about what numbers are not in your domain and then work around that. So right here I intersect, right here I intersect, right here I intersect, right here I intersect. If this kept going up and to the right, I would keep intersecting. And the idea here is that regardless of where I drew these vertical lines for these x values, like -9 and +8 and maybe like 12 and maybe like 20, I would always be intersecting my graph. So the idea here is, since all of these numbers are in your domain and there are no conceivable x values that your graph would not intersect that vertical line through, right? Then every number is in your domain, every x value. So your domain would be the set of all real numbers. And real numbers has a shorthand, and it looks like this. It is like this double R where you've got two lines and it makes an R. That is our abbreviation for real numbers. Okay, so all of the x values are part of our domain. Okay? Now, let's try to think about the range. The range is the same exact idea, except we are dealing with y values with the range. Y's. All right? So this is going to get kind of hard to see because I've got all this blue stuff everywhere, but just do your best to follow along. Now, you're imagining if the function here, the graph, was like infinitely spread out, right? Like if it went on forever and ever and ever. Now, for the y's, for the range, instead of thinking about these x values here making vertical lines, we're thinking about y values making horizontal lines. So you've got, say, the y value of 3, right? This is like y equals 3. If I was to extend this line, does it intersect with my graph? And the answer is yes. Right here it intersects, and right here it intersects, which is okay. So 3 would be part of my range. How about 7, right? 7. Is 7 part of my range? All right, think about that. Yes, because if I was to extend this way and extend this way, I touch the graph. I intersect with the graph. So 7 is part of my range. How about 10? Is 10 part of my range? Yes, because if I was to extend my line here, I would intersect with this graph. Most of this stuff that you would be doing, identifying the domain and range, you'll think about it in your head, and it'll eventually, hopefully, get to be really quick, really snappy with what the domain and range could be. So try to think of a y value that if you were to extend it, it would not intersect with the graph. All right, can you do that? I'll give you a second to think about it. And the correct answer is, like, there is a value. There's lots of values of y that would not intersect with the graph. Because if you notice, our graph does not go any farther down than this point here. So at -2, it does touch the graph, okay? It touches it. But at -3, it does not. So -3 is not part of our range. -2 is the last value going down that's going to be part of our range. So from -2 going all the way up, you intersect with the graph at some point. All right, do you guys see this? All these points going up, you'll eventually intersect with the graph. So from -2 going all the way up, those are the values that are part of your range. But going below -2, we are now not going to intersect with the graph. So the range would be, now you can say this many different ways. We will do it in like inequality notation here. So it's the set, I'm going to read this out loud. Your range is the set of y values such that, all right, so this is like such that, and this is the typical format. The range is the set of all y values, or the set of y, such that your y's are greater than or equal to -2. So we said that -2 was the very minimum number for the range, and all the values greater than that were part of our range, all the y values, right? So that means that the range is the set of y's such that y has to be greater than or equal to -2. Okay? Great. So, how about these examples? You go ahead and look at this first example. This first one's fairly straightforward. Try to think about the domain and range of these graphs, starting with example 2. So you think about it. Think about all the x values that your graph might cross and all the y values your graph might cross, and write that down in the domain and range, or at least think about it. Right, I'll give you just a second to do that while I'm busy coughing. So, and taking a drink. And who knows what I'm actually doing on my desk. All right, so your domain. It's definitely a set. Wow, that's the worst brace I've ever done in my life. All right, so it's the set, of course. It's going to be a set. Now you're thinking, if you have to imagine that the graph extended this way forever and extended this way forever. And you should realize that the domain is all real numbers, because all of these values of x will eventually cross or intersect your graph. Right here it intersects up here, any of these points it would intersect with. And that's because if you have a vague look at your graph, right? Something to ask yourself is, does the graph go forever in the left direction? And the answer is yes. This is continually traveling left. Yes, it's going up as well, but it's also going left. And then is the graph continually going in the right direction at some point of the graph? And the answer is yes. This bit of the graph here goes in the right direction forever. It's also going down, but it is making right progress. So is there any jumps in the graph, any holes? Does it stop at some point and pick back up somewhere? And the answer is no. It's consistent. It's not consistent. It's continuous, right? You could start somewhere and then just never pick up your pencil before you're done drawing the graph, right? If you had an infinite amount of time. And that means it's continuous, so there's no holes in it. And so if you can go forever left and you can go forever right, if you were to extend the graph, and there are no holes in it, no jumping, then that means the domain is all the real numbers. And then on the other hand, your range is the set of real numbers as well, all real numbers as well. Because you have to ask the same questions, but for the y directions. Does the graph go down forever? Is it going to keep going down? And the answer is yes. You're going to keep finding places to intersect here, because the graph continually goes down. Does the graph continually go up? Yes, so you could always find some intersecting y value spot, right? And again, it re-established that it is continuous. It doesn't have any jumps or anything. So if the graph goes down forever and it goes up forever, and there's no holes or jumps, then the range is all real numbers. Okay? All right. So now let's look at the next example. This is a more complicated example, and this is the very last one we've got before our homework. Now, oh man, that looked like a lot of problems, but trust me, it's not going to take very long. So the domain and range here. Now, does the graph go left forever? And the answer is yes. At this point here, it'll continue going up and to the left forever, right? Does it continue going to the right forever? Yeah, at this point here, it goes down and to the right forever. But it is not continuous. If you're thinking of x values, right? X values like these lines here. Actually, not those. These lines here, any of these lines, will not intersect with this graph. It's like a dead zone. So from here to here, we've got a hole in our graph, like it jumps. So these are values of x. You've got -3, and then all the values in between, all the way up to +1. These are like values of x that are not part of your domain, because your graph is not going to intersect with these vertical lines drawn through here. Okay? So these values are not going to be in your domain, but all of the rest of these values are going to be in your domain. So all these values are in your domain. So the idea here is you can write this a couple of different ways. Um, I'll write it in like inequality format here. If this is a -3 and this is a +1, right? So all the values less than -3 are okay, and all the values greater than +1 are okay. And the reason I'm not saying greater than or equal to and less than or equal to is because we have got open circles here to indicate that you're not touching -3, you're not touching 1. So your domain is the set of x such that x is less than -3 and x is greater than 1. Okay? So it's the values of x where x is less than -3 and greater than -1, or greater than +1. Does that make sense? I basically just wrote down this group of numbers as an inequality and this group of numbers as an inequality. And then your y's, your range is the set. And now if you think about this, yes, there's this dead zone here for the domain, but think about it for the range. Range is talking about like y values like -2 and -1 and 0 and 1 and 2. If you were to extend these, are you intersecting with the graph? And the answer is yes. You're intersecting at 2 points. Here you're intersecting at 2 points. Here you're intersecting at 2 points. And you're like, oh, well, what about right here? You've got this hole here. Surely you're not intersecting there. But if you draw the line all the way across, sure you don't intersect with this spot, but you do intersect over here. And if you were to go farther up, yes, this part of the graph will never come up here. But if you were to extend all the way over here, you do intersect with the graph. So that you cannot find some y value spread out left and right that you would not intersect with the graph, because you'd intersect here, way down here, you'd keep intersecting with this line if it would drawn out forever. So your range is all real numbers. And there you have it. All right, hopefully that made sense to you guys. Here's your homework. Go ahead and pause the video if you want to see it, or if there's other ways to view my homework assignments. And that lesson, it ended up taking longer than I thought because domain and range is kind of difficult to explain, but whatever. Hopefully you did okay. It's a 50-minute class period, so you still have quite a bit of time to work on homework. So have at it.